We're integrating trig functions, so you're all freaking out because you're like, oh, I don't know how to integrate. But remember, integrating is just the inverse of deriving. So if you know how to derive a trig function, you know how to integrate it. So let's take a look. Let's go back actually to our derivatives of trig functions, because basically the idea with integrating is you can just look and see, well, what function, if I took the derivative of it, would give me this, right? Okay, so we're going to go back. So the derivative of sine is cosine. So if you see the integral of cosine, it's going to be sine, right? The derivative of tangent is secant. So if you see the integral of secant squared, you're going to have tangent is the integral. Okay, if you see secant times tangent, the integral is going to be secant, because if the derivative of secant is this, then the integral of this is this, right? These ones are a little trickier because a lot of times you won't see sine or negative sign, you'll just see sine, okay? So if I saw the integral of just sine, what would it be? Well, it would be negative cosine, right? Because let's think about this. The derivative of negative cosine is negative sine, which is positive sine, right? So if I saw positive sine, I know the integral would be negative cosine. If I saw positive cosecant squared, I know the integral would be negative cotangent. If I saw positive cosecant cotangent, I know my integral would be negative cosecant. So let's go back to the integrals. And so again, you can go and just memorize all of these. That's awesome. I wouldn't memorize these ones unless you're really wanting to do reverse chain rule. Honestly, U-substitution is just as easy. Honestly, I think it's easier. So again, don't worry about the chain rule ones because we know how to do U-substitution and we can do that. But you just have to be careful with your signs. And that makes me laugh every time I say that because I think of like sine and cosine, not signs, because I'm a geek and I love math jokes. I could come up with a better one, but I can't right now. So again, if you see sine, what is the derivative of what equals sine? Well, the derivative of negative cosine would give me sine, right? That's the same with all of these. The derivative of tangent is secant squared. The derivative of secant is secant tan. The derivative of negative cosecant would be cosecant cotan. So basically we're just undoing deriving, right? But you'll notice here, I don't have an integral for tangent, right? The integral of cosine, the integral of sine, the integral of cosecant, the integral of secant squared. I have all of these, but I don't have an integral for tangent yet. And I say that because we're going to get an integral for tangent. Okay, so we got to integrate tangent. Now, remember that tangent is the same as sine over cosine. Okay, so tangent is sine over cosine. So let's take a look and see how we could integrate this. Well, I see a function and its derivative in the same integral, which makes me think I should do a U-substitution because I see a function and its derivative, okay? So if I do a U-substitution here and I call U cosine x, then the derivative of that is negative sine x dx, which means that dx is equal to du over negative sine x, okay? So let's substitute this back in and do our U-substitution and see what happens. Okay, so I have the integral of sine x over u du negative sine x. The sine x's cancel out, which is what we were wanting, right? And we have negative 1 times the integral of 1 over u du. And we know how to integrate this. I know our brains are a little mushy, but let's try. Integral of 1 over u is ln. So this is negative ln absolute value of u plus c. And then we resubstitute back in our u. And remember our u was cosine of x. So we have negative ln absolute value of cosine x plus c. So that's the integral of tangent. So what's the integral of cotangent? Same thing. Cotangent is cosine x over sine x dx. So we're going to do a u sub of sine x this time, because sine x is on the bottom, right? So we want our derivatives to cancel out. So when we do our u substitution, we want that cosine to, one cosine to be on top and one to be on the bottom. So du equals cosine of x dx. That means dx equals du over cosine of x. So now I can do my u substitution. So I'm going to put in cosine x over u du over cosine x. Cancel those two out, and I just end up with the integral of 1 over u du. Notice I have no negative sign because the derivative of sine is just straight cosine. Ooh, it keeps not moving up, it keeps writing on it instead of moving it. Okay, so then what's the integral of u? It's ln of absolute value of u plus c. And so then we sub back in absolute value of sine x plus c. So that is the integral of cotangent x. So if you can't remember that, you could actually do this every time. Like, you don't, this isn't one of those ones that you would like absolutely have to memorize, because you could just figure it out. But it's probably faster just to memorize it. Okay, so let's do some integration. All right, so let's integrate this one. -3 sine x. Okay, so we bring the -3 out. What's the integral of sine x? Well, what if I took the derivative of what would it give me sine x? It would be negative cosine x plus c. So this is -3 times negative cosine, which gives me positive 3. And that's it. That's the integral. It's not too bad, right? Okay. The integral of cosine pi over t. Now, here's the thing. Anytime you see anything other than x inside of there, or t, or just one variable, we're going to have to use a u substitution, because you can't just, I mean, this is like a function inside of a function, right? Pi t is a function. So we have to do a u substitution for this one. So we're going to call u pi t. That means du equals pi dt. That means dt equals du over pi. So we can do our u sub now. So we can go cosine of u du over pi. So I'm just going to write that out here, 1 over pi. Okay. Now I know the derivative of cosine. What's the derivative of cosine? Well, it's sine, right? Because if I took, not the derivative, sorry, the integral of cosine is sine, because if I took the derivative of sine, I would get cosine. So then I just do that. Now I put my u back in. My u was pi times t, so I have 1 over pi sine of pi t. Sounds like high t, like we're British or something. All right, and that's the end. Okay, next one. See, it keeps writing on it instead of, okay, go back. Instead of like just moving it. Okay, so first things first, I see that I have secant squared of something, and anytime I have something other than just y or x or t, just anything more than a variable, I know I'm going to have to do a u substitution, but I also knew that I was going to have to do a u substitution because I see a function inside of a function. Y cubed is inside of the function secant squared, and I see this function's derivative out here, which is like a big red flag that we need a u substitution, okay? So u equals y cubed. That means du equals 3y squared dy. That means dy is going to equal du over 3y squared. So I'm going to do my u substitution, and I'm going to have y squared secant squared u du over 3y squared. Now those y squareds are going to cancel out, and I'm going to end up with 1/3, and I'm going to put that outside the parentheses since it's a constant, secant squared u du. And this is easy. This is something that we know, right? To take, let's see, if I took the derivative of what trig function would I get secant squared? Well, the answer is tangent, right? So I have 1/3 tangent u plus c, and then I just replace that u with my original, which was y cubed plus c. So there you go. That's it. Okay. Ooh, this one looks really complicated, but I see a function inside of a function, right? So I see like a peanut M&M here, so I know it's going to be a U-substitution. And then I guess we'll think about that in a minute. The integral of secant tangent, it looks really complicated, but if you look back at your paper, you can see that it has an integral, or you can think about when I take the derivative of what, do I get out secant times tangent? Okay, so first we see a function inside of a function, so we got to do a U substitution, so that's 2x plus 1, so du equals 2 dx, yep, and then that means dx equals du over 2. So I can do my substitution now. So I have the integral of secant u tangent u du over all over 2. And since that's just a constant, I'm going to pull that out as 1/2 right here. Okay, now what's the integral of secant tangent? Well, that is secant. So I have 1/2 secant u plus c. So I took the integral. Remember, this is like a step everyone keeps forgetting, is like the integral is a function, so when you take the integral of something, the integral sign is going to get dropped, and we are like evaluating the integral now. Okay, so that equals secant 1/2 secant u plus c. Now we got to plug our u back in, so we have 1/2 secant 2x plus 1 plus c.